Thank you, Garth, and accepted for forgetting about me. But being a consultant, we sort of get used to that. And being a consultant's a lot like energy for waste, in that your clients tend to try and work something out themselves, and then they can do something else with that, and they get down to that last 3%, and they really need us, and that's when we're important. So, thank you for that. Look, I'd just like to open with a fantastic conference, and thank you very much for the opportunity to present. I hope that we can replicate something like this in other states. This has been amazing from not just a content, but the way the waste community is working together. It's really opened my eyes. So well done to everybody who's been involved in organising it and getting to this point. I don't like getting up here and talking about these things and making them infomercial, but I'd just like to touch on SMEC. It is actually Snowy Mountain Engineering Corporation. We are into about our 70th year of business. A lot of people, especially last night, come up to me and said, SMEG, oh, what do you think about those retro kitchen appliances? And I'm like, oh, I'm more of a stainless steel sort of guy myself. I can't help you out. So it is a little bit confusing, but perhaps I need to talk to our marketing department about that. I just want to share with you, I guess, a bit of a practical look at some things we've learned over recent years about feasibility studies in the waste energy space. The back end to this is a lot of it's been covered around policy and separation of waste streams and whatnot over the last few days. But I think there's some real valuable things that we've picked up along the way that you may go away and find useful. I've tried to not make it overly technical. I think the technical side of things you can go and hunt down and find yourself. But it's just really, do these things work? Can they work? How have we got them to a point where they're nearly commercial, and how things have really fallen off the radar? So, briefly, we'll go through, as I mentioned, the findings based on a number of feasibility approval studies. One thing about in Australia, look, we're not really experts on waste energy. Like, I know that's obvious, but we need to own up to that a little bit and utilise a lot of that technology and experience that comes from other parts of the world. And we need to utilise that effectively. We're very secretive. Every project I'm working on at the moment is subject to some of the tightest confidentiality agreements I've ever worked on in consulting. And that's good because it's protecting a big financial decision-making process, but also there's a lot that I wish I could just say to the next person, hey, this will work here, but you can't. So that's something we've got to work through. Logistics and levies, make or break of the whole opportunity. Feedstock and emissions, just touch on that from more of a practical perspective. A lot of the work we're doing now is not just about the energy that comes out the back end. Clearly this is an alternative to traditional waste management methods, but there is a lot of exciting things that we've been working on regarding not just producing energy, which I'll share with people, and ownership and supply. So it's a lot to get through in about 15 minutes, so I'll go my hardest. Okay, a couple of key limiting factors that I've found across the I guess my professional experience. The policy, it's been hammered a lot over the last few days. I'll leave it at that and keep moving forward. What I would love to see though is a federal policy which states can filter in underneath. That'd make it so much easier. Number two, the actual cost of processing, 160 to 235. This is one of the hottest arguments I get involved in. Everybody says, oh, it's 270, I can do it for 140 and this. Look, these are real costs we've worked out. I'm happy if you can find something more expensive. I'm happy if you can find something cheaper. I've tried to be general here. Probably a third limiting factor at the moment is seed funding. People have a great idea. They'll go and spend 100,000 or something on getting it up to a concept phase. There'll be an investor sitting there. I've sat across the table with investors with billions of dollars, and then there's this gap, this huge glaring gap where a local government or a proponent or somebody has to put $1 million, $1.5 million, $2 million of their own money in before the investor wants to know about it and before the proponent wants to go any further. And that's a big gap at the moment I'm finding. And it's really important that anything you put on the table, is completely scalable. And that has limitations around mass burn. Gasification, you can have dual lines, smaller lines, you can scale down. Obviously increases the cost, but it's very important that scalability, not just to allow future recycling, but future adoption of technologies that they're employing in Europe today. I was chatting to some of the WTT guys last night, and they were talking about how they get down to a very fine portion percentage of the municipal waste type stream, and the way that the automation process separates and whatnot, you know, it was really great to see the Cleanaway presentation. That's the closest thing I've seen to something in Australia. So that's really something that we need to consider if we're going to go down this path. As I mentioned, look, we're not experts, but we do know a lot generally. I think a lot of people, when they get into waste for energy, spend a lot of time on Google, which is good and bad. There's a lot of confusion between mass burn and gasification. And look, I'm not going to ignite a debate, excuse the pun, I didn't actually mean that pun, but I'll just say that there is variations in the ash and the end products which you need to consider. Syngas is a valuable fuel. Syngas can be refined as a fuel for other things downstream. Syngas is a potential way to get around maybe levies if you're producing a fuel from a landfill levy perspective. I don't know. Not game enough to test that waters myself, but hint, hint, if somebody wants to have a go, I'm really keen to find out how that goes. Emissions control, very different with both, and a bit more downstream emission control in mass burn, obviously. Mass burn in terms of capital can be much more attractive per tonne. The scalability of mass burn is hard. I think the previous presenter touched on some of that. You're locked into a certain thing. That can be a bit of a challenge. Both do need front-end waste treatment or they're going to struggle to perform. So great to hear that, you know, we're separating FOGO out as a completely separate, as you mentioned before, separate business. So that's quite an important factor as well. Very secretive. Look, I get why we're very secretive, and there's probably many people in this room who are in some way commercially involved, potentially in waste for energy or looking at it, but there is a lot of information there that we can tap into to help each other, and we probably should be working ways to make that a bit more effective. Fuel characteristics, awesome to see some of the research and work being done. That's one of the biggest issues. You walk into the Victorian EPA and you say, right, here's our fuel characteristic, and they go, right, what's the emissions going to be with that? Oh, they're going to be this. But what happens if you get the waste from this lower socio-economic area? Well, okay, well, we'll do a bin audit there, and then it's different. And so there's so much variability. The regulators are going to find it hard to pin something down. You don't want to have to go and redo this for every location you do a waste for energy plant. So it's not going to be an Australian standard, but it would be great to see an Australian standard for waste characterisation at some point in Australia. I think, you know, we're working towards that type of principle at the moment, but it is really important because it does have a lot of impact. Long-term feedstock supply, again, it's been touched on a lot. One of the challenges is investors, you know, Mr. Big Money Bags here is like, I want to know I've got ability to feed my plant for 25 years, Lucas. I'm like, right, go to local government, we've got a 3+3 year contracting type scenario or somebody else. And it just doesn't work. And we need to be able to provide them a little bit more comfort that we can adapt to the long-term supply scenario, so their investment will continue to progress and they won't just drop off the radar and go and put their money somewhere else. And I think as well is sharing a lot of this information is going to improve the ability for the investors to bring this money to the table quickly. It is a challenge and it's a long drawn-out process to get financial closure on projects, and it starts years before you get your approvals. So that's, I guess, something else that can help the sector. Logistics and levies. Look, I've had to fiddle with these figures a bit due to a whole range of confidential reasons why, as you can see some of the data there. But I've painted a bit of a scenario. So let's say it costs 80 cents a tonne per kilometre for a side lift truck, and we can fit 18 tonne in it. I get the variables. Direct dump needs to be within about 30 kilometres. This is based on a 100,000 tonne per annum gasification plant with two 50,000 tonne per annum lines. The theoretical levy, landfill levy of $100 a tonne. CapEx and OpEx, landfill costs $75 a tonne. Somebody's going to want to make a profit, so I'll say $20 a tonne, roughly. Bottom ash, fly ash, I haven't included in the fee. If you can get a market for that, especially the bottom ash, you're looking at about a $4 million return to your bottom line with some of the similar type products in the space. Even if you can dispose of it for free, it's a huge cost saving, because there is realistically a 20-25% bottom ash component to the type of projects we've looked at that still needs to be disposed. Again, direct dump to be competitive, that's at 30 kilometre range. Again, this is a 100,000 tonne gasification type process. There's going to be different scenarios, but I'm just painting the picture for something as generally as I can. And the ability to scale as recycling improves, again, is very, very important. So if you build a plant that must have 100,000 tonne go through it per year, and we're going to get better at recycling and a range of other things, and green waste bins and FOGO and everything else, you don't want a plant failing because it can't meet its performance criteria due to volumes of waste. So that's very important. Feedstock and emissions. Again, I'll touch on this standard for the feedstock. That's quite a challenge. It's very, very variable. It's very variable where there is green waste. It's very variable where there's FOGO. It's, you're looking at calorific values of low 7s through to potentially 11s and 12s, depending on what people are doing in certain areas. Commercial and industrial waste can improve the calorific value, reduce the ash volumes, but again, you need to be really picky with what commercial and industrial waste you get. And there's sort of people starting to twig on to what's CNI. They want 25% CNI blend to maybe 75% municipal. A lot of that potential prime CNI waste is already gone before a plant's even built. Non-ferrous metal removal, very important. Need to look at some sort of counter-current flow system to manage with that. Keep away from gyprock and plasterboard. Obviously has a range of issues with emissions. FOGO and green waste recycling behaviour. Again, it has a significant impact from a moisture content, calorific value. A lot of places are starting to adopt it. Make sure we continue to work on end markets for the FOGO and the green waste. We don't want to get to a point where we have this fantastic product that we can't use. I saw some tender documents recently for a project in North Queensland about a 10-year trial around FOGO and green waste going back into cane fields, and the significant benefits that it had in maintaining moisture content within the soil profile and also reduction of fertiliser. So I believe there is a very valuable market. There is a cost, obviously, of transporting it. The figures are being run at the moment on that versus the cost of fertiliser and everything else. Really looking forward to that. I think it'll have some quite positive spin-offs. And I guess the efficiencies of the plant are significantly affected by the variability of waste. If you get a whole heap of metal get through, you get blocked up grates, you get a range of issues. If you get a lot of green waste and FOGO through, moisture content goes through the roof, you're not going to get the performance out of your plant, you're not going to get your emissions you require. So it's really critical that upfront separation and is well thought through and actually delivered. This is something I've been doing quite a bit of work on of recent times, which has been actually quite interesting. It's looking at what you can do downstream of the actual, or with the heat source. So obviously heat needs a co-location, unreal in Europe, really difficult in Australia to justify heat as a product from energy for waste with a commercial value or any other value, or social value for that matter. But if it was to be co-located with feedstock plants and pelleting and something like that, it does have a use. But again, that's not comparative to the amount of potential energy for waste market we've got. Steam, C.1, a little bit more benefit with steam, production, manufacturing, etc. If we are going to really have a go at downstream processing of our recycling, it needs a lot of heat and steam. Ideal to have these things co-located. There is starting to be waste management precincts set up around Australia, and it's exciting to see that there will be demand for steam and heat in those. Obviously power, that's what these plants are, everybody thinks of initially. But with the power, I guess, value adding battery supplies. We've done a bit of work around looking at actual battery supplies for peak demand, and you can get like a 5-time benefit on your return by being able to spot market that power source. during that time if you can put batteries on the back end. Again, that's very, very early in its life cycle and stages, but it's showing some significant benefits. RO plants is another option on the back end, co-locating these facilities with a source of water that needs some sort of treatment for a particular another purpose. Very intensive energy project process, obviously RO, having the ability to utilise that heat potentially as a waste or something might be more beneficial than the energy recovery. And again, just reiterate what everybody said, waste for energy is an alternative to landfilling, and we need to keep reminding ourselves of that, but we can make it appear a bit better than just a burning process. And we can do better things with the energy out the back end than just burn. Ownership and supply. So a lot of interest around waste for energy from superannuation funds at the moment. So they seem to be very keen. They are investing in them. Some Australian superannuation funds own parts of waste for energy assets in Europe. Interest in Australia in investing in them. They see it as a long-term stable return. Very large capital outlay, obviously, to set one of these facilities up. Makes local government ownership very hard to justify. Detailed cost-benefit analysis and financial model may actually surprise you when you offset against landfilling and various other scenarios. Again, its size, throughputs have a big bearing on that. There is a lot of variables in the end figures. Finance is a complicated and long-term process. One of the particular projects we're looking at the moment is probably one of the soundest projects that I've been involved in. And they've knocked on the door of all range of financial institutions in Australia and have got absolutely nowhere. The funding looks like it'll come from a number of areas overseas, but again, there is just so much concern around the financing of this at this stage. Once we get a dozen of these plants up, who knows, it might be a lot more generous. But at the moment, I think a lot of the proponents feel like a first home buyer. It is really challenging to try and get off that first base. So, and that's purely because of the track record and the risk and the issues of long-term supply contracts and these types of things. So they're all areas that we also need to educate the finances on to get into the next space. Onto it. Long-term feedstock supplies. Grid connections are a big issue. We've been doing a lot of work in solar farms. About 7-8 years ago, the solar farm industry is probably where the energy for waste industry is today. A lot of scepticism. One thing hasn't changed, grid connections are a really long, drawn-out process. If you're looking at energy for waste and you want to have a plant in 2 years, start sorting out your grid connection tomorrow. It is really, really complicated and long-winded. Just finally, something to consider. I deliberately haven't gone down the path of greenhouse gas and CO2s. There was a question on that before. It's because we've had so many different reports done which consider so many parameters. The variance in the capture of that cost of landfilling versus energy for waste is like this. It is huge. I'm going to go with 40% today. I know there's people in this room who are going to say it's many more times that, but either way, 40% is a significant cost as compared to traditional landfilling from a cost perspective. And if you add that up across Australia, landfilling and transferring energy for waste, if it was ever to happen, there is literally millions and millions and millions of dollars in savings and cost recovery around one to the other. But again, that's a separate study for somebody who's got the time and a lot smarter than I to undertake that to get an accurate standard. Because it is, every report, every project is different. All right, I hope I kept on track and kept everybody awake. And any questions?